So number 2, we have a security camera. It's going to be mounted 8 meters above the ground. Okay, so I have to make the diagram here. All right. Looking for my pen. There it is. I got a security camera mounted 8 meters above the ground. That sounds like this to me at the moment. 8 meters above the ground. It's outside a front wall of a building. Police investigators are using the camera to determine the angles of depression of 2 vehicles parked directly in line with the camera. Okay, so here's my ground, right? Here's my camera, C for camera, and there's 2 cars along the ground. Well, one of them must be a Honda, right? So H for Honda. And the other one's going to be a really cool Subaru, so it'll be S for Subaru. Okay. And we're looking for the angles of depression parked right in front of them were 23 and 58 degrees. So the camera has a line of sight to both of them like this. A line of sight to the Honda like that, and a line of sight to the Subaru like that. And the angles of depression have to be from the camera, because that's what they said. So your horizontal has to be from the camera. And we're looking for angles of depression. One of them's 58, so one of them's bigger than the other, right? So the bigger angle of depression is going down to the Honda, isn't it? And the smaller angle of depression is going down to the Subaru. So it's kind of counterintuitive, but the larger angle of depression is to the car that's closer. Now that kind of makes sense if you try to think about looking at your shoes. If you go to look at your shoes, you got to bend way down to see your shoes. But if you want to see something that's a couple meters ahead, you only have to bend your head down a little bit, right? So that's kind of what's happening here. Using our Z pattern, you know that this is going to be parallel with this, which means that this is going to be a 23-degree angle on the inside here, and this big one is going to be a 58-degree angle. Let me see, zoom. Yeah, here. Okay. All right, we're assuming that the wall to the building is 90 degrees. And the question is really how far apart were the vehicles? So I think what they're asking is how far apart are the vehicles from the building, but no, probably not. They're asking how far apart the vehicles are from each other. So this value here, x. Okay, so I've got a bunch of things happening here. We've got the 8 meters, we've got the ground, we've got some angle measurements, and I want x. I'm going to call this, let's call it B for building, base of the building. So now I've got 2 triangles. Do you see them? I've got triangle CBH and I've got triangle CBS, and they're both right triangles. There's actually a third triangle, and that's CHS, but it's not a right triangle, right? And we haven't talked about non-right triangles at all yet. We will, but we haven't yet, so that's off limits. We're not going to deal with that triangle. So if I take a look at triangle CBH, I could figure out the length of BH, do you agree? Because that's going to be adjacent to 58 and 8 is going to be opposite. So someone in the studio audience asked me earlier, how do I come up with this so quickly? Or how do I come up with it at all? I look at this. This is my reference angle. This is my opposite. This is my adjacent. That's my hypotenuse. And I have memorized my trig ratios. So if I want opposite, and if I want adjacent, and I've got opposite, let's call this adjacent. I need to call it something. Can we call it BH? We'll just call it BH at the moment. If I want BH, I want adjacent, I've got opposite, I've got an angle. That's going to be tangent. Tangent deals with opposite and adjacent. You just got to know that. So tangent of 58 degrees equals 8 over BH. And that's the distance from the base of the building to the Honda. So my unknown is in the denominator, so I need to cross multiply. BH times tan of 58 equals 8. Divide both sides. BH equals 8 divided by tan, 58. Using my calculator, 8 divided by 58 tan equals, and the distance from the building to the Honda is going to be approximately 4, well, it's not 4, is it? It's 5.0. Okay, because I had to round that. So it's approximately 5.0 meters. So this bit from here to here is 5 meters. Now, if I move into a different triangle, if I look at triangle CBS, that's a really bad B. And I didn't even put the triangle symbol there. Wow, that's bad. In triangle CBS, so I'm going to look at this side, which is 8. I'm going to look at this entire distance, though, from B to S now, and I've got an angle. So I know that it's going to be tan of 23 degrees will equal the opposite over BS this time. Okay, we're going to cross multiply. We're going to get BS times 23 degrees equals 8. We're going to get BS equals 8 over tan of 23. So 8 divided by 23 tan equals, it's approximately 18.8. And again, I'm rounding to 1/10 of a meter, so to 1 decimal place. So I have the big length from the base of the building to the Subaru. I have the distance between the base of the building and the Honda. That means the two cars will be separated by, therefore, distance between the cars is the big length, subtract the little length, so it's going to be 13.8 meters. And that's how you do that question. All right, I'm going to stop there.